Okay, so here's another one where we want to find everything. The function is given here. The first thing we want to find is increasing, decreasing, relative extrema, and critical numbers. That all comes from the first derivative. Okay, so let's find the first derivative. This one, because we have it written as a product, we want to do this by the product rule. Yeah, we could expand this, but that's going to take too much time. I think it's easier just to use the product rule. So we've got the first thing. When we do the derivative of the second, that requires the chain rule. So 3 comes down, x minus 2, subtract 1 from the exponent, but then don't forget to multiply by the derivative of the inside, which is going to be a 1. So this whole thing here is the chain rule using the derivative of the second term. We have plus the second piece, x minus 2 cubed, and then derivative of the first going to be times 1. The best way to do these kind of problems where you have multiple things like this, you don't want to expand all this out because that's going to make the problem a lot more complicated. What you want to do is look for common factors and factor it out, because then you can get your answer put in a factored form. Alright, so doing that, we have the one that repeats is x minus 2. The most you can pull out would be the lowest power. So I'm going to pull out x minus 2 squared. That's the most that you can pull out of this. Now when you remove that term, what do you have left? We have 3x here, if you take that out of that one. Here you have x minus 2 to the third power. We're taking out 2 of them. So it's going to leave you with x minus 2 left over inside there, and the 1 we don't need to worry about. Next, we're going to simplify inside the parentheses now that we've taken out the common factor. X minus 2 squared, you'll get 4x minus 2. But it's always best to factor this down as much as possible. So here there's a factor of 2, we can pull the 2 out front. So if we do that, we'll get 2x minus 2 squared. If we factor out a 2 from this, you'll get 2x minus 1 left over. So now this right here is going to be the most factored form of that. And so this is the one we want to look at when we set it equal to 0. We find critical numbers by looking where this is undefined, but again, there's no place where that's going to be undefined, so we'll just go directly to setting it equal to 0. When we do that, we're going to get x is equal to 2 and also 1/2. These are your critical numbers. Critical numbers we're going to put on our number line, and this is where we're going to look for relative extrema and also increasing and decreasing. You want to do some test points. So less than 1/2 we'll use 0. In between we're going to use 1.5, and then greater than 2 we'll use 3. Again, I'm circling these and writing them underneath so that way I don't get this confused when I write my intervals of increasing and decreasing. I don't want to grab the circle values by mistake. Here's the first derivative. This is where these test numbers are going to go into, and we're going to indicate whether we get a plus or minus when we plug these in. 0, I'll plug into each of these. Now the first piece, because I have a square, that part's always going to be positive regardless of what I put in there. The second one is what I'll look at. So if I put a 0 in here, I get a negative 1. So positive times a negative will give me a negative result there. Next, 1.5. We know this is always positive, so we move on to here. 2 times 1.5 is 3 minus 1, gives you a positive there. Then you put in a 3. This is positive always. This part will be positive, so you get a plus on that end. So this is our final sign configuration. We're ready now to write the conclusion here. So if we're going to write the intervals of increasing, where you see pluses there. Now I am going to split this up because at 2, technically the derivative is 0. It's not increasing or decreasing. So I have from 1/2 to 2, and then from 2 to infinity. That's my intervals of increasing. Next, I have decreasing. That's where I have a negative sign. Negative infinity to 1/2 is where I have a minus. It's decreasing. What I can also find is my relative extrema. I have a relative min at 1/2 using the first derivative test, negative to plus. So that's going to be 1/2, and then I got to put 1/2 back into the original one. If you put 1/2 in there and work it out, you can work that out on your own. You'll get, I'll just give you the answer, negative 27/16 is what you'll get when you put 1/2 back into that one. And then there's no relative max. There's a plus and a plus. So at 2, that's not going to be anything. It's no relative min or relative max. We found all the information we can from the first derivative. So now we want to do the second derivative. So I'm going to transfer the answer we got here, the first derivative. I'm going to go ahead and write it up here for us. And then clear out some space. So for this we we want to take the derivative of the first derivative. That's going to give us the second derivative. And that's going to involve a product rule also. I'll do it down here so I end up having enough space to write this, expand this all out here. Alright, so when we do this, here's the first piece and here's the second piece. I have the first piece times the derivative of the second. The derivative of the second is 2 plus the second piece, 2x minus 1, times the derivative of the first. Derivative of the first is going to involve a chain rule. 2 comes down, multiplies by 2, I get a 4 there. X minus 2, subtract 1 from that power, and I get a 1. This is going to be the whole thing using the product rule for the second derivative. Again, for this, you always want to factor it before you set it equal to 0. Now 2 times 2 is 4, and I have a 4 here, so 4 is going to be one of my common factors. And then I have x minus 2, that's going to be another common factor. Okay, so if I take out x minus 2 from here, I'm going to be left with another x minus 2 when I take that away from this power. And then I have 2x minus 1 left over. Technically I don't need the parentheses here. 2x minus 1 will be left over there because I'm taking this whole thing out, and that's what I'm left with. So this is the part I'll have left over on the inside of the parentheses once I factor this piece on the outside. Next, we're going to simplify this inside the parentheses. Okay, so when we do that, 3x minus 3. But then you can factor out a 3 here. I'll do that up here. To get the second derivative, that's going to be a 12 actually, because you're taking out a 3 from here to multiply by the 4. So 12, x minus 2, and then x minus 1 you'll have left over there. This is going to be your completed second derivative, fully factored. It's this one that we're going to set equal to 0 to get the possible inflection points. Again, you don't know if they're inflection points unless you look at the sign chart, but these are the numbers that will go on the sign chart. You're going to get x is equal to 2 and 1. Put these on the number line. We have 1 and 2. Remember, this time we're putting test points into the second derivative. We're going to put in a 0, a 1.5, and a 3. 0 goes into the second derivative. 0 minus 2 and 0 minus 1, you'll get negative, negative will give you a plus. 1.5 in here will give you a negative. 1.5 minus 1 gives you a positive. So you'll get a negative as a result in the middle. 3 minus 2 is positive, 3 minus 1 is positive. So you get plus, minus, plus there. This is your final sign configuration. So we can now indicate the intervals of concavity. Let's first start with concave up is where you see plus signs. Concave up, negative infinity to 1. And then we have also from 2 to infinity will be the other place where it's concave up. And then we have concave down is going to be where you have a negative, so between 1 and 2 we have a concave down. Then you're going to look for any inflection points. The two inflection points you'll have there will be both at 1 and 2 because we have a change in concavity. And we don't know that for sure if it's inflection until we look at the sign chart. Okay, so inflection points we have in this case. First one's going to occur at 1. The 1 you're going to put back into the original one. If you do, you have 1 times negative 1, that's going to be negative 1. Remember, to find the point on the line itself, you got to always go back to the original equation. Next, you're going to put in a 2. If I put a 2 in here, I get a 0 there, so I get 2 and 0 as a result. Once you have inflection points, you want to find the intercepts. Okay? Now the x-intercepts you get by setting this equal to 0, setting the original one equal to 0. And you'll get 0 and 2, so 0, 0, and 2, 0 will be the coordinates for your x-intercepts. Your y-intercept is where you put a 0 in for x, and you're going to get 0, 0 again. 0, 0 makes sense because that's a x and y-intercept at the same time. It goes to the origin. Now let's do the graph of erase this. So now we're going to put all this information together. The first thing you want to start with is plotting any kind of points that we have. So intercepts or relative min and maxes, inflection points, you want to plot all those first. 0, 0 is an intercept, and also 2, 0 is an intercept. We found an inflection point at 1, -1. So that's an additional point. We already got the 2, 0. But we also have a 1/2 and a -27/16. That's our relative min. So -27/16 you can get a decimal for it, but it'll be slightly less than 2. So that's going to be somewhere around right here is where it'll be plotted. Now we got all the points. We're going to use our increasing, decreasing, and concavity in order to draw the curve. This is concave up from -infinity to 1, which means that it's got to be kind of curving up at that point. We also know it's decreasing from -infinity to 1/2, so know the graph is falling. So here's how it'll look when we put that together. It's going to go through that point, and it's going to curve and look like this. This is considered concave up. It's decreasing down to 1/2. Now, we have an inflection point at 1, -1. Concavity changes from concave up to concave down between 1 and 2. Now, it's still increasing, but the graph has to increase and curve down. What will that look like? It's going to look like this. Okay, notice it's concave down because it's curving down, but it's still considered increasing all the way from 1/2 to 2, like we originally said it was supposed to. Then at 2 to infinity, it's supposed to be increasing also, but at the same time, from 2 to infinity, it's going to be considered concave up. So that means it's going to be curving upward like this. So this is going to be your completed graph. Now the relative min, from looking at the graph, that just so happens to be our absolute min. There's no absolute max because that continues forever. This point right here, we originally found that to be a critical point because the derivative would be 0 there. However, it's not a relative min or a relative max because we don't have an increasing, we don't have a change in sign there. It's increasing and increasing, so we just have a bend in the graph. It's a critical number, but that's about all that point happens to be. It also is an inflection point because concavity changes. So this would be your completed graph.